Hello, everyone, and welcome to the OpenStack Infrastructure Summit. We are excited to be part of this. I am Saurabh Sureka, and along with me, I have Richu and Hunter with me. We are part of the OpenStack team at A10 Networks. And today we will be talking about the amphorae of application delivery and security with Octavia. The agenda that we plan to cover is, we want to walk you through the journey of LBaaS. LBaaS has its own journey since the OpenStack inception. We want to talk about the LBaaS plus amphorae that we bring in that enables both application delivery and security for OpenStack. Rich is going to help provide an architecture overview, the interoperability, deployment, and best practices using Octavia. And if time permits, we will have a demo that demonstrates the service orchestration and the per app analytics that we've enabled on OpenStack. A quick introduction to A10 Networks, who we are. So we've been around for about 15 years. We have about 8,000 plus customers, and we deliver and secure critical workloads at hyperscale. So we work closely with the leading service providers, with the web scalers, and the large enterprises to help with their application delivery and security needs. We are known in the industry for our best price to performance ratio, and that's primarily enabled by the performance that we enable with our flexible architecture. We've been associated with OpenStack since 2014 with the Neutron project. So Neutron was known as Quantum prior to that. And we've both, benefited from the community. So thanks to the developers out there. And then we've also worked closely with our customers to bring our services on their OpenStack infrastructure. The LBaaS journey. LBaaS was integral to Neutron. As you know, Neutron is the networking component. Since Octavia, it has forked out. It has its own name with Octavia. Now, Octavia brings in the concept of amphorae. When I heard the term first, I was mesmerized by it. So I looked up, and this is the word is derived from an ancient Greek terminology wherein the amphora was used primarily to both store and transport products like wine. And this happened in the Bronze Age around maybe 2020 BC. What better way, if you are looking to convince, the technical mind share, what better way or what better name to have than the amphora? So with Octavia, the LBaaS is decoupled from the OpenStack development. This is important, both from development as well as from deployment point of view. And the amphora can run as a virtual machine, as bare metal, or as a container. So this enables, the different type of application workloads, and depending on your use case, you can run the LBaaS either as a VM, bare metal, or as container. And it truly enables, the at-scale load balancing with multi-tenancy, which is required in today's application workload. So we bring in, with the A10 solution, we bring in an LBaaS plus. So it's basically our shiny amphora for your OpenStack infrastructure. So a typical mid to large deployment for OpenStack will have few hundreds of applications. And we enable three key things for your application workloads. The first and foremost is the availability. We make sure that your applications are always available. The second is security, both for the applications as well as the underlying infrastructure. And third, the important point is around observability. So the ability to have real-time view into your application traffic at a per app, per user level. So to expand on this, when I say availability, it's really enabling 5 nines of availability and 5 layers of availability for your OpenStack infrastructure. So the availability can be in terms of making sure your application is fault tolerant, making sure the application infrastructure is fault tolerant, the load balancer infrastructure, the namespace that is associated with the load balancer. If you have deployed your applications across multiple regions or multiple clouds, we provide fault tolerance across all of that. And this enables, the BCDR type of use cases. So if you want to have even intelligent traffic management for your applications, wherein the infrastructure that is closest to the user serves that particular user, so you can enable it with our service. Especially, we also enable the blue-green type of deployment. So this is important, when your dev team wants to push out some changes for a select type of users, and then you want to ensure you have a smooth adoption for your application. And thirdly, the custom application health checks that can be enabled right at the HTTP layer or at TCP/UDP, the network layer, or even at the application protocol layer. Talking about security, we enable defense in depth posture for the application workloads. So starting from the secure connectivity end-to-end between the user to the application enabled by SSL TLS, IPsec. So this is primarily for either a site-to-site or from a client-to-site type of connectivity. Then we enable application access management, which is providing you with single sign-on, multi-factor authentication, enabled by our integration with the IDPs. The third thing we enable is the DDoS protection, both at the network layer as well as at the application layer. And then finally, protection from the bot or the malicious traffic. We also have the web application firewall that protects your application from the vulnerabilities of, like common common scripting attacks and so on. Talking about observability, we enable real-time observability at a per app, per flow level. This is done without having any kind of agent in between. We've built the Smartin at the load balancer and streaming capability for to our controller. So this enables quite a lot of new use cases around predictive analytics, providing with actionable insights, and importantly around alerts and notifications that can be configured easily. So all of this can be is API driven. So if you want to integrate this into with your SIEM vendor or your components of the infrastructure, you can easily extend it yourself. So this solution is enabled, our LBAS can run either as a high performant hardware, as a VM, as bare metal, or as a container. We bring in high performance with our integrations, around SRIOV, DPDK, so you can run our software as a single instance, 100 gig. And then you get the same feature functionality across multiple clouds. We realized that there is a need to automate the workloads as well as automate the deployment and configuration of the load balancer. So we have a strong support of automation tool chain we enable. The other thing, we hear from our customers is they are looking for a self-service portal for their workloads. And they have two primary user personas. This is around the NetOps and the DevOps. So the NetOps team is primarily responsible for the lifecycle management of the load balancer, and the DevOps are responsible for their view into the application traffic, so things like configuring WIP or just looking at the application health check. So we enable both those use cases with Harmony Controller. So for if you have hundreds of applications, you can if you are a DevOps, you can zoom in to your specific application and get real-time visibility about 200 plus parameters that can be used for advanced analytics as well as for alerts and notifications. So simple use cases, if you are running into an application error, you can easily configure a webhook as well as post a message into your Slack channel. So that way it will alert you the moment the incident happens. And this is enabled in OpenStack as well as across the hybrid cloud. So with that, I'm going to pass it over to Richu. Richu, over to you.
Thank you, Saurabh. So what we're going to start off with is I have a few slides here to introduce what Octavia is as part of the OpenStack releases. And then we'll walk you through the A10 Octavia provider driver. So here, Octavia is an operator scale load balancer as a service, which has been made available on the OpenStack release since Liberty. On the back end, Octavia uses the amphorae driver for scaling and on-demand load balancing creation. So a multiple of these amphorae are called amphorae, and each of them can be deployed as either a virtual machine, a container, or a bare metal. What this brings to the table is it makes this amphorae driver truly supportive of different form factors for load balancing. And horizontal scaling is what differentiates Octavia from its predecessor, the Neutron LBAS. Basically, it adds more machines to the pool of resources that's made available, making it extremely supportive of the multi-tenancy for customer SLAs and security associations. So interaction with the OpenStack components, Octavia interacts with Nova, Neutron, Barbican, so on and so forth, through the provider driver interface, which is basically a superset of the LBAS v2 APIs, bringing the flexibility of flavors for different sized VMs, and also making it easy to create these custom provider drivers for integrating into Octavia. Basically makes it supportive of modern cloud deployments. Next slide, please. Here I'm kind of summarizing the Octavia architecture into three key components. Amphorae, right? The individual load balancer is called an amphorae. What's natively available as part of Octavia is an Ubuntu VM which spins up with HA proxy. Then you have the controller, which is essentially the brain of Octavia, which has 5 daemon services running. They are the controller worker driver, the health manager, housekeeping manager, and so on and so forth. Each amphorae comes up with a network interface on the load balancing network. So what this essentially provides for you is a direct connection into the tenant network so that you can access the tenant servers. Next slide, please. So as part of the A10 provider driver for Octavia, what we've done is basically consumed the natively available Octavia APIs and customized it for deploying, configuring, and managing A10 load balancers. And in this case, A10 load balancers get deployed as amphorae. So our focus with the provider driver is that we keep it highly scalable, highly available, and make it easy to automate these configurations, which are A10 load balancer specific. So the 3 microservices, to make this provider driver actually easy to manage, deploy, what we've done is built out our own 3 microservices which run as the daemons here, specifically the Octavia worker, health manager, and housekeeping manager. And we've also attached it to the A10 controller worker. For SSL-based secrets, we leverage the Barbican, A10 Thunder, and I'll go into the deeper use cases and functionality that A10 Thunder provides, but in this specific case, it's the SSL termination, or what we call SSL offload. Next slide, please. Okay, so here, so A10 Octavia provider driver is now available, and it's also publicized on the OpenStack webpage. The link here that we have is our GitHub page, where you can go, sift through the documentation, also download the package. We have more resources and links to resources at the end of this presentation. This is just one of it. Next slide, please. Okay. I'm going to focus on some of our top key functionalities that we've enabled for A10 Octavia provider driver as of the stained release, September 2020. Of course, there is a lot more functionality that we are planning to enhance on. The top would be that we've enabled today is layer 4 network load balancing and configuration and automation through the provider driver. Layer 7 application load balancing through the provider driver. Layer 7 HTTP rules and policies, which then get configured as aflexes and bound to the load balancer. Advanced health monitoring, again, this can be application-based, this can be network-based for your backend servers and services. And the speeds and feeds required for that, again, natively available through the provider driver. SSL offload or SSL termination, we're using Barbican, as I mentioned, for storing the SSL secrets. Another key functionality, one of the most popular use cases for A10 load balancers through the OpenStack integration. The next one would be the hierarchical multi-tenancy. Now, this is a key feature, like we already spoke about, as part of what Octavia brings to the table, right? So what we've done is enabled the hierarchical multi-tenancy, which ranges between your domain, your tenant, domain project, and your tenant. And this achieved through layer 3 virtual partitions within the A10 load balancer, if it's to do with the hardware kind of deployments, and similar or individual VMs if required in case of the A10 vThunder or the virtual Thunder deployments. So high availability cluster, of course, A10 active standby mode deployment. And we also provide something called the VCS, which is the A10 load balancer clustering to aggregate resources and provide you more throughput and more performance aggregation. And the HA, the high availability for redundancy and failover. With VLAN support, we basically provide you this single aggregator, which can be split into multiple partitions, and then you could use differentiation of your customer engagement through the VLANs. And all of this A10 Octavia provider driver, which can integrate into A10, the bare metal or the hardware solution, the virtual solution called the vThunder, or even our container solution. We also have the A10 Octavia config file, which gets into the more nitty-gritties of A10 specific configurations. Next slide, please. With this, we'll move on to the demo. And for the demo, Hunter will join us as well.
I'm Hunter Thompson. I'm the engineering lead for A10's OpenStack team. I'm going to be giving a demo today covering how to configure and orchestrate vThunder devices, among other things, in the OpenStack environment. But before we get there, I'm going to show just the very basics of Octavia. So first up, we have the load balancer, which is just the IP address. You know, it's essentially your VIP. We have the listener, which is actually sitting there. It's listening for the requests that are coming through. In this case, we're going to have an HTTP listener. It's going to sit there on port 80. We have two backend member servers. Those are sitting inside the sales pool, which will have the round robin load balancing algorithm directing traffic between them. Also today, we're going to be showing the A10 Harmony controller just to show the analytics and the traffic that are flowing through to those backend servers. So in this section, I'm just going to show the config really quickly here. Just that we have the controller worker, our health manager, and the housekeeper, which are Octavia microservices running there in the background. So here I'm creating the OpenStack load balancer itself. In this case, we're going to be creating the VIP on this provider network, which is just directed at VLAN 111. Now I'm going to be showing that we have our amphorae created on the admin project. And if you look on the right side of your screen there, you can see the journal entries where it's logging all of the commands and information that's being sent over. So now I'm actually going to hand it over to Richu, who's going to cover Harmony, as we are about to start sending requests from our client there to the VIP and then onto the servers so we can get some analytics off that.
Thank you, Hunter. So we are going to log into the Harmony using your regular web browser.
Yeah. Yep.
And A10 Harmony is can run as a VM within your OpenStack host network, and here that's what we've done. As you can see that it is a per, as I'll show you actually, it is a per app visibility deep analytics platform, which plugs into the A10 load balancers and of all form factors across virtual and hardware and containers, and gives you the deep analytics. So as you see here, we're looking at the cluster where we have two of the A10 Thunder devices which are clustered, and Thunder 1 is our that's the master and the active device. We'll go into the Carp A tenant to view more deeper analytics. In the analytics dashboard, as you log in, you'll be able to see the inventory, and here in this case, we have the Infra Summit demo. And looking into the analytics here, the analytics is kind of divided across every layer of the transition of the packets. So here you see that we have the first client tab, then you have the internet. Within the Thunder cluster, you have the cluster tab. If you had enabled web application firewall, which is the WAF analytics, you could see that in there. ADC service is what we've enabled, which is the server load balancer, the VIP analytics and details, which we'll tap on and look further into. We also can record and monitor your server and application health. So first, we're looking at the client page. You can see the request location, the request methods, the response codes in detail. As you hover over it, you see more details. You can click on that and log into and get the list of incoming requests and tap further into that. I'll show you a dashboard which does just that. So the peak time in which you received more requests in this case, we seem to have sent a lot more requests at 1400 today, 1400 o'clock today. Within the operating systems, you see that we have sent requests from the macOS, the Windows, Linux, Android, etc. I think Hunter is also going to send some curl commands for the iOS. Tell us more, Hunter.
Yeah, I'm going to just simulate an iOS command here. And then we have to wait on Harmony to refresh. It polls every once in a while. So while that's happening, we're actually going to go back to the L7 policy, the L7 rule. In that, I had said that if we see a header with reject and then bad request, we will just reject and drop the request. So we can see that there. And if we change it up and we do something like good request, it'll just let it through just fine there. And now we can see that and after refreshing, we can see that iOS has been added.
Thank you, Hunter. That was really useful. Now we're looking at the browsers. We've been sending some curl commands from using Firefox and just curl, which shows up as unknown, and Chrome, of course. And here you can see the throughput. To dig deeper into per packet analytics, we also show that here in the minimize tab, which we've pulled up. And as you can see, the granularity is extreme. In order to troubleshoot, this is an extremely useful tool. You can choose across the browsers, you can choose across the client operating system, the device, the client IP, the URLs, the request type, etc. And it gives you all the packets that were logged with these selected details. Looking at the applications, you're able to tell the response time of the application latency. This gives you a very good detailed view about your application health, something that helps the app developers to look more deeper into. Top domains and URLs that were targeted, application servers, there's the server health and the server response time itself. That brings me to the end of this demo.
All right, thank you, Hunter, and thank you, Richu, for the demo. This is the final call to action slide. So, if you are looking at the OpenStack Octavia project, and if you would like to partner, we are here to help you. So especially, a lot of customers, a lot of users are actually moving away from the Neutron LBAS to Octavia. So we'll be more than happy to engage with you all. So especially if you're looking for high performance VNFs or even for cloud native solutions. And a lot of people are, looking for that consistent application delivery and security across the hybrid cloud infrastructure, right? So we'll be more than happy to collaborate on that. And in below here, we have some important links, so the email ID for any open source project is opensource@a10networks.com. The GitHub, the page that's actively updated and visited, it has the A10 Octavia project list here. The provider plugin and the driver that Richu talked about on the OpenStack page. And then finally, the PyPy package if you want to just download and install it in your environment. So again, thank you everyone. And this is what we have for today. Thanks for joining.